Yum, yum!
Greg here from Pixel Fondue. In this video, I am going to show you how to constrain an item like a buoy or a boat or a float or an inner tube or whatever, dead fish maybe, to a water surface where it's going to go up and down with the surface, and also tilt with the troughs of the waves. So it should also get that nice sort of like rocking motion. And then we'll put a little bit of an oscillating spin motion just to sort of finish it off. And yeah, so it's actually a little bit trickier than I thought. I needed Lukash's help, Lukash of Auto Character Setup fame, ACS3. He actually got the constraints working right for me. But I do a lot of water videos or animations, and so if you're doing that as well, this can help. And so let's check it out. So we'll just go to a new scene here. And you don't need a buoy. You can just use a cone or a cylinder or cube or whatever, or you can get a buoy. I actually got this from sketchfab, and sketchfab, this one is made by MisterH. So thank you, MisterH. This is, a lot of their stuff is downloadable. Tons of stuff is downloadable, and you can use it in things like this for educational purposes or just learning how to use stuff. Practice, just to attribute, make sure you do a Creative Commons attribution. So this is to MisterH, and I'll put that in the description as well. But there's a bunch of buoys on there, and there's some to buy too if you're really into it. So let's make some water. So I'm going to press N for a new mesh item, hit enter, and type in water. Just call it water, and then let's just do a procedural water. So type tab and then cube, and then pop open your mini props and turn size of Y to 0 because we do not have a plane primitive in MODO, which would maybe be nice to have. But segments to 10 on X and Z. Actually, let's do segments to like 50 to make it more dense, and that'll be enough to get some water deformation going on there. Space to dismiss the mini props. And then I'm going to add a transform effector, and this will let me move our waves into place. Right now, if I just move this transform locator here, it just moves around that whole mesh. So let's modulate it with a fall off, right? So we'll do a texture fall off. And the texture fall off is going to use a waves texture, and we'll also add a ripples texture and sort of blend them together. So we'll just add a waves texture here. And if I move my effector up like 0.1 or something, you'll see it moving that wave into, that wave will start to take shape. Our waves are too big though, so select the wave node and then just go to wavelength right here, maybe from 1, which is pretty big for a 1 meter plane, right? So we'll just change it to like 0.33, so a little bit better there. And then I'm actually going to go to the texture locator tab and rotate it 45 on Y just to get some directionality to it. It's actually kind of a little bit too high there, maybe like a little bit lower on our locator. And then if I hit play, you'll notice that it's not moving. So there is a time attribute right here. If I drag on it, you can see it's moving in time. So you can animate that. You can keyframe it if you want to. I'm actually going to make it procedural. So I'm going to open up my schematic over here. And I'm going to drag that time node, not node, but channel on the wave node right over there. And just hit tab and type in time into the search bar. And you'll get the scene time node. This is the scene time. So we're going to basically feed this time slider into this channel, right? By just going time to time. And then when I hit play, you'll see that it's all movie there, right? It's pretty fast though, so let's slow it down with just a multiply node. So tab, type in multiply, get that basic math multiply. Maybe change it to like, I don't know, 0.3 on the value B and plug time into value A, and then plug the output there to time. And now we're going 3 times as slow, so it looks pretty good, I think. Then let's just do one more texture. We're just going to layer them a little bit. You can actually layer textures right here, the texture fall off schematic here. So by the way, you can work with this in a tree or the schematic. So if I want to just drag these things into the schematic, I can. You can see that I've got my textures here, right? Waves are going in there. And I can add a new one from the schematic by hitting tab and typing in like ripples over here if I want to, or if I can actually spell. I can get ripples over here, or I do think it's easier to work in a tree most often. You just click there, then just again just type in ripples. So there's a couple different ripples textures. I'm going to grab one from the enhanced MODO textures right here. And then because it also has that time node that we like, so I'll drag that time node back in. You can see that the ripples texture is here. You can see it's layered here the same way, you know, bottom up, waves first, ripples second, waves first, ripples second. And this time node right here, we'll just get that going in 1 second. Let's just change a couple of things with the ripples. Right now, the ripples are totally overriding the waves, just like it would in the shader tree. It's just layered, just plastered on top of it. If I disable it, you can see that we've got the waves back. If I enable it, now it's just the ripples. So let's lower the wavelength and the ripples as well to like 0.25 or something, so something like that. And again, if I disable it, there's the waves, enable with the ripples. So I can adjust the opacity here just to sort of mix them if you want. I'm actually going to leave the opacity at 100. I'm going to change the blending mode. I'm going to change that to overlay. And I think that gives a better effect. And overlay mode works just like in Photoshop, where it compares the values of the two textures, the ripple value and the wave value. And if the ripple value is higher, I believe it does a screen operation. And if the ripple value is lower than the wave value, it does like a multiply operation. So it just adds a lot of contrast there and sort of blends them together that way. So that looks pretty good. There's the animation, but the ripples aren't moving, they're just the waves. So let's get the ripples to move too. And I'm gonna add another multiply node, just because I think I'm gonna want this at a slightly different speed. So this one, let's do like 0.15 and then get time into here and then just plug that into time. And then if I close the schematic and hit play, you'll see that we've got a nice combination of things going there. If you want bigger waves, you take our transform effector and you move it up. And if you want smaller waves, you move it down. So there we go. We've got water, we've got waves. We'll finish this off by a couple things. Let's change our scene to like 600 or something. I already have it there actually. Just a longer duration so it doesn't constantly repeat on you while you're playing it. And then let's just add a quick material tag mop mesh op there. We'll call this water. There needs to be a button right here that you click and it creates a group in the shader tree with a material in it. If it doesn't already exist, and that way you don't have to go here and add your own group and then connect it to water and then add your own material. That's sort of annoying if you ask me to have to do that every time, but yeah, let's make it sort of bluish, and I've got a blue background here, so maybe we'll make it sort of greenish blue. And yeah, so let's take a look at this. We've got the waves going, but there's no deformation or there's no movement happening on our buoy. So let's get going with that. Double click escape to drop everything. And let's add a locator. So press L in the, close this mesh op list here, I think. Press L to add a locator and drag it up a little bit. I'm gonna actually grab the water and the transform effector and the texture fall off, and I'm gonna group them. And we'll just call this water group. Theoretically, I can hit enter and call it water group. And then I'm gonna hide the texture fall off and the transform effector. I don't need to see them in the viewport. And this new locator, let's call it ray gun. We'll call it ray gun because it's actually going to shoot a ray down at our surface. I'm going to move it up. So press W and move it up. Now it's make sure that locators are visible. So Control 1 and to the pie menu, toggle locators, and you'll see it right there. It's kind of hard to see in the advanced viewport. And 17, by the way, I think makes locators easier to see. This is still 16.2. Also, if you can press O and just make sure show locators is on if you don't want to use the pie menu. But I am going to use the Eteria kit I have here in my shelf to change the shape of this. You can also do this down here under display, add draw options. This is just a better way of doing it. And I'm going to make it a circle on the Y, and I'm going to make it a lot smaller, like 0.02. And I'm going to maybe make it sort of an orangey, like a sort of dark orangey color there. And so there's our locator, and this is going to shoot a ray down into the water surface. In fact, I'm going to hide the buoy right now. We're going to have it shoot a ray down to the water surface and create a new locator at the surface where that ray intersects. So there's a couple things we have to do because the default options aren't ideal. So I'm going to select the ray gun, and then I'm going to control select the water. And that's how you do any sort of constraints in MODO. Select the item you want to constrain to the item you want to control select to the item you want to constrain to, right? So I've got those two things selected. And then over here on this little setup tab, this little rigging tab here, we want to go to the constraints vertical tab. And this down here at the bottom is surface constraint. I'm going to click that, and you'll see it created a new locator down here on the surface. And so first thing I'm going to do is I'm just going to drag it up. We'll call this surface loc. Whoops. And then I always think it's worthwhile taking the time to name your locators and change the shape to something better than just the standard sort of axis. So with this one, we'll just do like a cube, and we'll make it really small again, like 0.01, control enter, maybe 0.02, control enter, and then we'll do like a white outline with, we'll just do that sort of burnt orange again, like that. And so there's our locator. And if I drag forward, you'll notice that it's moving with the surface, but it's sort of dancing around. And we don't want that. Now, if I go over here to my ray gun and click the little plus sign and get to the intersect node that's underneath it, you'll see its mode is set to closest. And you'll also see this little ray. It's easier to see in wireframe being shot down, right? It's shooting it down, but it's just picking the highest peak of the closest wave, right? So we don't want the shortest distance between the points. We actually just want it to go like a ray, but we don't want it to go off into Z. We want it to go into Y, and then we want it to go negative axis, so it's straight down. Now it's going straight down, and we've got our locator just going up and down as the waves go by, right? So that's looking pretty good. That's what we want. And because if I then turn my buoy back on, and then I parent it to that surface locator there, and then hit play, now our buoy is going up and down with the waves. So we're halfway there, right? We got it going up and down, but we don't have it doing the tilting. And so unfortunately, we're not halfway there because the tilting is the hard part. So I actually needed the help of Lukash, who the programmer of ACS3 at Auto Character Setup 3, to get this right. Because actually, the default options which you think would work don't actually work. You need to do put a little more effort into it. So if you're thinking, well, we should just constrain it to the normal of one of these polygons, and as this polygon changes, right, you know, as it goes like this with the waves going by it, then we'll just have that normal. If you want to see the normal, press O, and under active objects, click, I believe there's a normal, show normals somewhere. I swear it's on here. Maybe it's visibility. Show selection normals, there it is. So if I select this guy, and again, I'm going to go to wireframe, you see that little dotted, that's the normal, right? And as the waves go, as we go forward in time, you'll see that normal is going to change with the way the wave is pointing, right? So that's the idea. We want to constrain the direction of this buoy to that normal. So as the normal changes, the buoy tilts back and forth with these undulating waves. And what it'll do, if I go ahead and I take this surface locator, we're not going to constrain the buoy itself. We're going to constrain that surface locator, all right, just to give us some more flexibility with the buoy later on. And we're gonna so same thing. So select your surface locator, and then control click the water, and then you're going to click polygon normal. Okay, a couple things happened here. You'll see that our guy tilted on its side, and if you look, you'll see that the Z, the blue icon is now, or not icon, but the blue axis is now sticking up. So it's constraining the Z axis to the normal. That's just the default. And what it does is it gives a little bit of an offset here, where I can turn this offset. I can just go back 90 degrees and put that upright again. And so now you think we're doing okay. We're constraining to that polygon underneath it. Also, by the way, you can see that index right there, 1224. If I'm going to hide my buoy here. If I come in here and I pick this polygon and go over to stats and info, you'll see the polygon ID here says 1274. So it's one of these, 1224 right there. So what it is, it just grabbed the closest polygon, right? So 1224 is the closest one. I believe you can also like show those IDs in here, but I don't know that we need to do that as well, and I can never remember which one it is. Show indices, I think maybe should work. Yeah, so you see the little white letters there under show indices. It'll tell you what that polygon ID is, and that's what's in the polygon normal constraint here. So if I change the ID to like, this one over here, which is, if I put on my glasses, like 1134, maybe 1184. So if I change this to like 1184, you're going to see this buoy change direction. Right? So now it's matching this one. So that's how that works. That's how the constraints work. And you think like, okay, awesome. I think we're done. I think we got it. Now I hit play. The problem is it's rocking back and forth, which is great, which is what we want. But it's also spinning around, right? It's just spinning around, spinning around. It's kind of like an inverse kinematics, an IK problem. That's why you have things called up vectors to keep things in the just always pointed the right direction. So it's pointing the right direction in that it's on its, it's pointed up and it's rocking back and forth. But we want, for instance, this side of the buoy to always be facing this direction, right? We don't want it to be spinning around like a clock on there. So we need to do a little bit of extra work here, okay? So let's open up the schematic and drag our items in there. So I'm going to grab the surface locator and the ray gun and the intersect. We'll drag all these guys in here. And so just sort of, let me just collapse this for a second and get this cleaned up. I would kill, whoops, come on, collapse. I would kill for some sort of auto, like MODO's nodes are just the worst case scenario for like a clean layout. They're just, oh my gosh, so much work needs to be done. Anyway, so we've got our water going into the our ray gun going into the intersect node, right? Intersecting with our water, which is also going in there, and it's outputting into our surface locator to get that up and down motion. And then we also have our water with that particular polygon selected going into our polygon normal constraint, and that's going into the rotation, which is half working. Got to get rid of that spin. So here's what we're going to do. We're going to change this for this 90 degrees offset, which sort of tilted our buoy back up. We'll just put it back to 0 for now, and we're going to unhook it. So now our buoy is just going up and down and up and down. And then I'm going to add a couple new locators in the scene. So press L and add a locator. We'll call this point A. And then I'm going to duplicate it and call it point B. And so what we're going to do is we're going to have two locators. We're going to create a line by offsetting them. We're going to constrain this bottom one to the ocean just like we did before, so it goes up and down. And then we'll do the polygon constraint, so it tilts with the waves. But then we're going to do a directional constraint with an up vector to get rid of that spinning motion that sucks, right? So bear with me. It sounds complicated, but it's not super bad. So here's point A. I'm going to drag it into the scene. And I'm going to go over to the channels. I'm just going to select world position and world rotation and drag them in here. So you can see the little locator there. Let me hide the buoy for now. And in this locator, I'm just going to, again, just to make it visible, we'll just make it a cylinder on Y. Actually, not a cylinder. Let's make it we'll just make it like another, oh geez, what should we make it? We'll make a sort of a flattened cube on Y. So 0.1, 0.05, 0.1 maybe, something like that. That's way too big, so a little bit different than this. Let me just I know it sucks to take up tutorial time with me screwing around here, but it'll help you see it in the viewport. So something like this, color, and maybe 0.05, 0.03, 0.05, something like this, right? So there it is. And I'm going to take our same intersect output that got our surface locator constrained to the surface and plug that into this locator. So you'll see it snap right to where that orange one is. Boom. And so now it's also moving up and down. Sounds good. And I'm going to take our polygon normal one and I'm going to plug into the rotation. This is going to do two things. Remember, it's going to point the Z back up because it just automatically, or by default, constrains the Z axis to the normal. So I'm going to plug that in. And now the Z is facing the direction of that one polygon I pointed out earlier. I think that one like right here, I think it is maybe. And then I'm going to take point B and I'm going to parent it to point A. And I'm going to press, go to item mode, press 5. And I'm going to move it along Z and I'm going to move it up. And we're also going to give it a sort of another sort of box look here. So we'll just do like 0.02 or 0.05. That's still too big, 0.01. And then again, make it sort of purpley. And so there we go. So this guy is parented to this guy, and as they're moving, it's still flipping around to the ocean. So it's got that tilt right with the waves going up and down, and it's got the motion right with the waves going up and down, but it's doing the exact same spinning we had earlier, but we're going to get rid of that with a directional constraint. So let me grab point B and drag it in here as well. And again, I want that world position, so I'm going to drag that in from the item list. You can also right click, by the way, and just go to add channel world position if you want rather do it like that. And then I'm going to add one more locator here. I'm going to call this a up vector. And we're just going to move it just off to the side on Z only. So off like, minus, like 0.5 on, or maybe 0.2 on Z, minus 0.2. Actually, could probably go either way, but that's fine. We'll go minus 0.2. And we'll just make this, again, I'm going to change the shape here to just another cube. And we'll just make it like a green cube. Like that. So there it is right there. Like that. Okay. And so let's go ahead and add a directional constraint to the scene. So tab and type in direction. Now we have a directional constraint. And this constraint is going to take a position from and a position to. That's going to create like a line. And it's going to constrain something between that point there. So like that sort of pointy thing from the bottom here to here, right? It's going to constrain in that direction. It's going to output that. So position from is from the bottom one here, right? World position. Position 2 is from the top one here, world position. And now we can send this output to our original surface locator here that this buoy is attached to. So we'll just sort of stretch this one out and say the rotation is going to go in there. And you'll see it snap aligned to that. So we'll turn the buoy back on. Now don't worry about it being on its side. We're going to get to that. So go to the directional constraint and change axis to Y. It's going to pop that back up. And now we've still got the spinny because we haven't added the up vector, but we're about to do that. Now all this would be useful if this polygon normal had an up vector. We wouldn't have to add these other nodes. Seems like it, I don't know if it can have one, but it seems like that should work. But what we'll do is we're going to select the directional constraint and we're going to select our up vector. In fact, I'm going to bring this up vector into the world here. It's going to sit right there. And we're just going to select our directional constraint and the up vector. And on the directional constraint here in the properties, this says assign up vector. Click that. And it just did that. So now this is hooked up to the up vector. And the up vector in this case isn't up, it's to the side. But what it's doing now is it's just always going to face that. See, we've got rid of the spin because it's not twirling around now. It's always going to be facing this guy. So if I move this guy, I can change the direction of it, right? It's always going to face it. So I can animate this guy if I want to. If I want to like sort of get a little bit of an arc animation in here to animate it during the scene. If I want to animate a little bit of a roll. But right now I'm just going to leave it there. And I'm going to do that a slightly different way. But just let's take a look at this. And we've got it going up and down. And it's following the motion of the ocean. Like it's rotating and stuff. But one of the things you'll notice is it's a little bit chonky, right? It's a little bit jerky. And what's interesting is you see how it's kind of, hopefully the frame rate's going through on YouTube, but it's just a little bit jerky in my opinion. And one of the reasons is it's taking the normal vector of a really small sample area, just one of these little polygons here. In fact, if I take this water and go back to the cube and I change the segments from like 50 to 16, and so the polygons are much bigger, and hit play, and it's much smoother. It's just a much smoother, it doesn't have that sort of jerky, stuttery thing because the polygons are bigger, it's a bigger surface area, and the normal doesn't sort of change direction as quickly. So I think this looks better, and I think we need to fix it. So this is what we're going to do. So what I'd really like to be able to do, ideally, it'd be nice to be able to grab some of these polygons here. underneath your buoy and just sort of grab the average normal and feed that average normal into this Polygon normal constraint, or rather we have multiple indices and it just does an average. But we don't have that unless somebody makes it for us. Maybe Steve Hill can make one, or somebody like that. But unless we have one, we can't do that. So let's do something a little bit different. Let's make a new water item. We'll just call this water for normal. And we'll just use our mesh items, mesh operations to create a sort of a proxy water for that. So we'll just do a cube again. And this time we're going to do, maybe, 12 or so. Maybe we'll do 16 different instead of 50. And let me just hide the regular water here. So we've got this one here. And then I'm actually going to just feed in some of the stuff we already have in the water. So here's our water right here. And it's got, this material tag and the cube and the transform here. And we just need to borrow this transform, or we just reconnect into it. So I'm going to grab our water for the normal in here. And you can see there's our cube, right? And the next thing we're going to do is just plug this into the transforms. So we're going to plug it into the transforms here, and you'll see that we've got the cube and the transforms. We're just going to move the transforms on top. So again, our original water has a cube with 50 subdivisions, and it has the transforms and a material tag. And then our water for normal has the cube with just 16 subdivisions, and we just plugged into the same transforms. You can share mesh operations in MODO if you want to. And you can see that we've got the ripples there. We don't need the material tag for this because we're just going to hide it. But it's just going to give us a little bit of a better, or just a bigger surface area to grab our normal information from. So here we've got a matrix compose, and I'm going to pull, that's using the world position, rotation, and scale from our water. And I'm going to unplug those. And this is plugged into our normal, just so you can see everything on screen here at once. So we just keep that same node in here, but we're gonna take our water, our sort of low res water, and get our world rotation, scale, and position. Drag them in, keep them selected, hold Shift, and drag those into the matrix inputs. Okay, and then we just need the mesh channel. So I'm gonna unplug the mesh channel from the old water, unplug that, and then we're just gonna add the mesh channel into the schematic from for the new water, and plug that in. Now remember, we have a Polygon ID on here. I think this is, you just want to go above. And again, if you press O and make sure show indices is on, I mean, any polygon you select will have the indice right there, and a very tiny print that you will probably not be able to see. But I'm going to grab this one, and that is, actually, honestly, this is where I put on my glasses. 119. It's 119. Sure would be nice to make those bigger. So for the constraint, we want indice 119. And I'm actually going to take our ray gun locator that we had at the beginning, and I'm going to drop that right in the middle of that. It's going to bring our entire rig. We can just put our whole rig anywhere with this ray gun one, because all the positions are just, this is that intersect. All the positions are from all these other locators are derived from it. So I'm just going to set it right on top of that polygon number 119. Is that 119? That is 120. Where's 119? There's 119. So I want it right there. This is what happens when you turn like 50. You can't see anything. So 119, there it is. And so it's centered on top of that polygon that's constrained to by the normal, which is good. And then I think that's about it. Let me just go back here. Now we can just hide our that water right there. That's getting the normal information for the constraint. Turn on our other water. Now this is gonna just, see, there's no more jerkiness anymore. It's nice and smooth. Looks pretty good. If I want to just sort of wrap it up and get a little bit of oscillating motion on the twist, I can do that. So, the up vector, there's a couple ways you can do it. We can look at, go back to the schematic. And if you look back here at our directional constraint, it has a roll channel. So I can adjust the roll, and it's going to adjust the roll of our buoy. So I can just kind of drag on this. You can see it kind of rolling like that. So if I want, I can drag the roll channel into the schematic like this, and there's the roll channel right there. And then I can add let's just grab a node called oscillate, channel oscillator, that's what it's called. And I get it, yep, right here. And so the amplitude will go like 45, and because it's oscillating like a sine wave, it'll go from like positive 45 at the top to negative 45 at the bottom. And I'll just plug that into the roll, and you can see it kind of twist there. And now it's going way too fast, but we'll adjust it. So let's just turn the frequency down to like 0.1 or maybe 0.05. And so it's just adding a little bit of a roll in there, just a little bit of back and forth on the roll, just to give it a little more of a realistic motion. And there we go, looking pretty good. So I think we should, so yeah, the jitteriness is smoothed out. That's the big thing. So if you want to use displacement instead of, well, I'll just show you. If you want to use displacement to get the waves instead of this transform effector, let's just go back into our schematic here real quick. And with waves, you need a pretty dense mesh, and that's where we sort of ran into problems with getting the polygon normal orientation right. And if it's a really vast ocean and you have a ton of polygons, it can really slow you down. So sometimes it's better just to use displacement mapping. But we want to be able to get this sort of basic bouncy the motion on the displaced waves as well. So what we can do is, again, we've got our water for normal here. And we've got our regular water here. So what I'll do is I'm just going to unhook our transform from the regular water, so it flattens out like that. I'm going to have our ray gun shoot into our, let me just turn off the water here and turn on our normal water. I'm going to have it shoot down into the normal water instead of, or the water for normal rather than this water. So again, I'm just going to undo the mesh here, and then I'm going to hook up the mesh to this intersect right here. So let me just push this over so you can kind of see what I'm doing. The intersect is going to want the mesh input from our low res water, right? And it's going to snap, I'll just move this back. And it's going to snap our buoy down to it. So now the buoy is getting all its rotation and position movement from the low res water, which we're going to hide, and we don't need, right? And we're going to turn on our higher res water, which has no deformations on it now, but we're going to use displacement mapping to get the water there. So let's just turn on our rendering over here. And then if you want to find out where, if I look at our transform effector, remember we have the waves and the ripples. Those in the shader tree are located here under the nodes folder. So I can just select them both, and I can right click and say create instance, and then drag them into the water mask. And I just want the ripples on top like they were down here. And then I want their effect to be displacement. So under surface shading, select displacement, and you can see over here, let's just make the water sort of it's kind of hard to tell what that is actually. Let me just adjust this material so you can maybe see it a little bit better in the viewport there. So let me just turn it a little bit darker. And we can just maybe bump up the displacement amount a little bit from 20 millimeters to, I think I had it about I think I had it around 80. So something like this. And then it should, you can see it just works just the same, right? It's aligned, it's aligned with the waves. It's pointing the way it should be. It's going up with the waves. It's going to go down with the waves. And so you can use displacement, using those same textures. And because they're instanced, I should be able to just, change, let's say the wavelength here, and it should change both the rendered displacement texture and the wave texture on our just proxy water there. So yeah, that was it. I know it took a long time to get there, but really the only problem we ran into that doesn't keep you from doing this in just 2 minutes is that the need for the up vector, and that's where it gets a little complicated. And then even then with, I really think MODO needs a feature where we can average normals and constrain to like a average group of normals, whether it's verts or edges or polygons. I think that'd be a better constraint. In fact, the whole constraint system in MODO, it seems like I'd rather see a sort of a stacking list like this, like that we have for mesh ops, than what we have now. The constraints in MODO sort of arrived before the mesh op stack, so maybe that's something for the future, but hopefully this was useful. One note, if you do render in Octane, you're going to have to, you can't use Octane procedural nodes in fall-offs in MODO, and the MODO textures don't work in Octane, so you're going to have to bake out a texture map for the ripples and waves, and then just project that as an image projection in Octane onto the surface to get displacements in Octane.
Yum, yum!